Good morning. Today we are going to start a topic from part 1, pair of straight lines. Actually, in part 1 there are 7 topics. The first topic is mathematical logic, second is matrices, third one is trigonometric functions, fourth is pair of straight lines, fifth is vectors, sixth is line and plane, and seventh is linear programming. So we are taking fourth topic, that is pair of straight lines. And obviously for this, what is required? The part which we have done in 11th standard, right from concept of locus to geometrical interpretation of u plus kv equal to 0, that is family of lines. I have uploaded one PDF. I'll show you that. See, this is that PDF in which important points from 11th standard topic straight line are included, and after that theory part from 12th standard. You should know everything about this distance formula, section formula, and so on. Now the topic, as I said, is pair of straight lines. Now an equation which represents two lines is called the combined equation of those two lines, or joint equation of two lines. First, we are going to discuss an important result. You can call that as theorem, that combined equation of two lines, say u equal to 0 and v equal to 0, is what? uv equal to 0. That is, uv equal to 0 represents the joint, that is combined equation of pair of lines. Let me explain the proof. Suppose u is a1x plus b1y plus c1 equal to 0. You know that general equation of line is what? Ax plus by plus c equal to 0. And suppose v is a2x plus b2y plus c2 equal to 0. Now consider the equation uv equal to 0. Suppose x1 y1 lies on the line u equal to 0. I'm saying that x1 y1 lies on which line? U equal to 0. Then it will satisfy the equation u equal to 0, and therefore it will satisfy the equation uv equal to 0 also, because 0 into v, see, this point need not lie on second line, but 0 into that is going to be 0 only, right? So can I say that every point on the line u equal to 0 lies on, now many students say lies on the line uv equal to 0. That is wrong, because uv equal to 0 does not represent line, it represents pair of lines. So I will just say that every point on the line u equal to 0 satisfies the locus. I can call this as a locus. Which locus? uv equal to 0. Similarly, every point on other line v equal to 0 will also satisfy equation of the locus uv equal to 0. Is that clear? Now conversely, let the point x0 y0, let the point x0 y0 lies on the locus uv equal to 0. Now I am saying that this point lies on which locus? uv equal to 0. So it will satisfy the equation, right? Because if a point lies on the locus, coordinates will satisfy the equation. That clearly shows that it satisfies at least one of the two equations, u equal to 0, v equal to 0. See, this is not at all difficult. If x0, y0 lies on the locus, then coordinates will satisfy the equation. This means x0, y0 lies at least on one of the two lines, u equal to 0 and v equal to 0. And therefore, I can say that uv equal to 0 represents the combined, that is joint equation of lines u equal to 0 and v equal to 0. Is that clear? Now I can say that as uv equal to 0 represents the joint, that is combined equation of pair of lines, u equal to 0 and v equal to 0 can be said or can be considered as separate equations of the lines. Separate equations of the lines represented by what? uv equal to 0. Now the next part is homogeneous equation of degree 2. Let us first define degree of a term. The sum of the indices of all variables in the term is called the degree of that term. Clearly, degree is a non-negative integer. Consider the expression. Consider the expression x raised to 4y plus xy square minus 7. Now, what is the degree of x raised to 4y? It is 4 plus 1, that is 5. What is the degree of xy square? When I say xy square, by that I mean x raised to 1 into y square. So the degree is 1 plus 2, that is 3. And what about degree of constant term? It is nothing but 0. Is that clear? Now, homogeneous expression. What is the meaning of homogeneous expression? A polynomial expression in which all the terms have the same degree is called as homogeneous expression. For example, x minus 11y, then x raised to 4 minus 17x cube y minus 11y raised to 4. Can I call these expressions as homogeneous? Yes, because in this expression, degree of each term is the same, it is 1. Here, degree of each term is the same, it is 4. So all these, rather both of these are what? Homogeneous expressions. Then comes homogeneous equation. An equation is said to be homogeneous in x and y if the degree of each term is the same. Or you can say that if you equate a homogeneous expression with 0, you get homogeneous equation. So I can say that x minus 11y equal to 0 is now homogeneous equation. Or on the right hand side, if I say it is say 13 x square y square, is this a homogeneous equation? Yes, it is, because all the terms are having the same degree. Now in this topic we are mainly interested in homogeneous expressions and then homogeneous equations of degree 2. Now can you tell me the different terms, different possible terms? They are x square, xy and y square. So if a homogeneous equation is of degree 2, then there can be at the most 3 terms. A term in x square, a term in xy and a term in y square. See, this is not at all difficult. Still one student is asking, please explain the concept of homogeneous equation. Okay, I will. See, logic is very simple. If the degree of each term is the same in an equation, then that equation is called as homogeneous equation. Now, what is the degree of a term? It is sum of the indices. Now, clearly those indices should be non-negative integers. So, if the degree of each term is the same, then that expression is called as homogeneous expression. You may also ask, sir, you just said that degree of 7 is 0. So how can we call x plus y equal to 0 as homogeneous equation? Because what about 0? Here degree is not 1. Okay, I will say this as x equal to minus y. Now see that the degree of each term is the same and it is 1. So yes, this is a homogeneous equation. So in short, remember that if you equate homogeneous expression with 0, you get homogeneous equation. Okay. Now next important part is we are going to show that the joint equation of pair of lines through the origin is a homogeneous equation of second degree in x and y. I will tell you the statement of theorem once again because we are going to discuss the proof also. The theorem is the joint equation of a pair of straight lines through origin. Actually, in this topic, there are two parts. In the first part, we are going to consider two lines strictly passing through origin. That is, each of the two lines passes through origin. And in the second part, we are going to discuss joint equation of any two lines. Okay. So the joint equation of lines through origin is a homogeneous equation of second degree in x and y. We are going to prove this. Let the two lines through the origin be a1x plus b1y equal to 0 and a2x plus b2y equal to 0. Okay. Now consider the locus represented by, see I'm using the word locus, represented by a1x plus b1y into a2x plus b2y equal to 0. This is the locus. I say that this is equation number 1. If x1y1, if x1y1 is any point on the first line, see the cursor. If x1y1 is any point on the first line, then a1x1 plus b1y1 will be 0. So in that case, a1x1 plus b1y1 into a2x1 plus b2y1 will going to be 0 only. Why? Because I'm not sure whether x1 y1 lies on this line or not, but x1 y1 lies on the first line, so this part is 0. See, in the beginning only I have explained this. This is repetition actually. So 0 into this is going to be 0. I hope you are getting this. Similarly, if x1 y1 lies on second line, in that case what will happen? a2x1 plus b2y1 is going to be 0. So we are sure that this part is 0. 0 into this is nothing but 0. In some cases, x1, y1 will lie on both the lines, point of intersection. So obviously, this is going to be 0. This shows that any point on the first line lies on the locus represented by 1. Similarly, every point on the line, second line, a2x plus b2y equal to 0, also lies on the locus represented by 1. Right? That is, this equation contains both the lines. Is that clear? Okay. Now, conversely, if x0, y0 is any point on the locus 1, if x0, y0 is any point on the locus 1, I can say if a point lies on the locus, coordinates will satisfy the equation. Right? Now tell me, if this product is 0, either a1 x0 plus b1 y0 equal to 0 or a2 x0 plus b2 y0 equal to 0. That is, at least one of the two should be 0. Both can also be 0, but at least one of the two should be 0. Is that clear? And therefore, I can say that any point on the locus 1 lies on the line, either first line or on the second line or on both the lines. So the conclusion is equation 1 represents both the lines jointly. That is, equation 1 is the joint equation of pair of lines. I hope that this is clear to you. Now, if I open all the brackets, as I said, there is going to be a term in x square, a term in y square, and a term in xy. And therefore I consider general second degree homogeneous equation as ax square plus twice hxy plus by square equal to 0. See, I have already explained the reason. Why to consider 2h? Why not to say ax square plus hxy plus by square equal to 0? Because in case of circle also you will remember we consider equation as x square plus y square plus not gx but plus 2gx plus 2fy plus c equal to 0. Why? Is it wrong if we just consider g and h? No, that is also correct. But if we take 2g, 2f, then we can obtain center and radius easily. Similarly, if we are interested in obtaining separate equations and so on, it is better to consider 2h instead of h. I repeat, ax square plus 2hxy plus by square equal to 0 is the general second degree homogeneous equation in x and y. Okay. So we have proved which theorem? The joint equation of pair of lines through origin is a second degree homogeneous equation in x and y. Now I'm going to ask you one question. Can I say that the converse of this theorem is true? Let me tell you the converse first. That general second degree homogeneous equation in x and y, that is equation of this type, represents pair of lines through origin. You have to tell me whether this statement is true or not. Very good. Most of the students have given the correct answer that the statement I made, which is converse of the given theorem, is not correct. So I can give an example. X square plus y square equal to 0. Does this equation represent second degree homogeneous equation in x and y? Yes, it does. Does this equation represent pair of lines? No. In fact, this represents a point circle, right? And therefore, the combined equation, listen to me carefully, the combined equation of a pair of lines passing through origin is second degree homogeneous equation in x and y, but every homogeneous equation, see the word every homogeneous equation of second degree in x and y need not represent pair of lines. Okay, example I have already given. But if I make some changes, or if I say that every homogeneous equation or homogeneous equation, not every, homogeneous equation of second degree in x and y in general represents pair of lines through origin. Yes, this statement is correct because I'm saying in general, and therefore we are going to use one theorem. I'm going to explain the proof also. The wording is every homogeneous equation of second degree in x and y, every homogeneous equation of second degree in x and y, that is ax square plus twice hxy plus by square equal to 0 represents a pair of lines through the origin if, or I should say, if and only if h square minus ab is greater than or equal to 0. I will repeat the statement. This equation represents pair of lines through origin if and only if h square minus ab is greater than or equal to 0. So we are going to discuss proof of which theorem? That equation ax square plus 2hxy plus by square equal to 0 represents a pair of lines through origin if h square minus ab is greater than or equal to 0. Now consider a homogeneous equation of second degree in x and y, that is ax square plus twice hxy plus by square equal to 0. This is equation 1. Now a, h and b are what? They are arbitrary constants. Means their values are not fixed. So I have to consider number of cases. Let me explain first. If you have any difficulty, you can ask me later on. First, I say suppose b equal to 0. Now when I say b equal to 0, clearly a should not be equal to 0 and h should not be equal to 0. Right? Suppose b equal to 0. Then in that case, equation becomes ax square plus twice hxy equal to 0. Now I can take x common to get ax plus twice hy equal to 0. So either x equal to 0 or ax plus twice hy equal to 0. Now, do these equations represent lines through origin? Yes, they do, because x equal to 0 is nothing but y-axis. This definitely represents line through origin because it lacks the constant term. Okay, so I have considered the first case, b equal to 0. So a and h cannot be 0 at the same time. This is possible. What? That b is 0 and h is also 0. So we get x square equal to 0. So it represents two equations, x equal to 0, x equal to 0. That is, equation represents y-axis twice. Now you may ask me, sir, but equations are the same. Have we said that two distinct lines? No, we have just said that two lines through origin. So two lines can be identical, coincident. Okay. So this is the first case. Now in the second case, I will say a equal to 0, b equal to 0. Let me explain first. A equal to 0, b equal to 0. So when I say a equal to 0, b equal to 0, clearly h is not equal to 0. Otherwise equation will be 0 equal to 0. There is no point in that, right? So h not equal to 0. So equation becomes twice hxy equal to 0. So I can divide by twice h as h not equal to 0, xy equal to 0. Separate equations are x equal to 0, y equal to 0. X equal to 0 is y-axis, y equal to 0 is x-axis. Do these axes pass through origin? Yes. In fact, point of intersection of these two axes is nothing but origin. And therefore, in this case also, equation 1 represents lines through origin. Now, third case is important. Here I am considering b not equal to 0. So if b is not equal to 0, I can divide throughout by b. I'm talking about this equation. We are going to divide equation 1 by b because we are considering the case in which b is not equal to 0. So if I divide by b, I get what? Y square plus twice hxy upon b plus ax square upon b. Is that clear? So after dividing by b, I get y square plus twice h upon b xy, okay, plus y square equal to, plus the next term is what? Ax square upon b, because I have written y square first only. So this is nothing but ax square upon b equal to 0. Now consider these two terms only, first two terms rather. Using completing the square method, I can say this can be square of what? Y plus h upon bx. See, what is a plus b square? A square present plus twice ab present plus square of the second. This term is not there. So what I do is I have unnecessarily, I will not say unnecessarily, I have added h square x square upon b square. To make hisab barabar, I will subtract h square x square upon b square. So have I written the same thing? Yes, I have. Okay. There is one more term plus ax square upon b. I have to write that also. So it is important that we are writing the same thing. We can write the given equation in different form, but we cannot write altogether different thing. Is that clear? Now next step, y plus h upon bx square, shift all terms, remaining terms to RHS. So x square upon b square minus ax square upon b. What is LCM? LCM is nothing but b square. So numerator is x square minus ab x square. Okay. So y plus h upon bx square. I'm explaining all the steps. Now from numerator I can take x square common. So h square minus ab into x square upon b square. Now we take roots on both the sides. So y plus hx upon b is plus or minus root of h square minus ab into x upon b. Now a good student will appreciate this. Yes, root of h square minus ab. This clearly indicates that for this equation, for equation 1 to represent pair of lines, this part cannot be negative because root of negative number is not real. Next step, I write this as, because a line through origin has equation in which form? Y equal to mx. We have done this. So bring hx by b to right hand side. So it becomes minus hx upon b plus minus root h square minus ab into x. X is outside the radical sign. Okay. And therefore I will say that two separate equations are. Before that, LCM is b. So minus hx plus minus root of h square minus ab, it should be. H square minus ab into x. Okay. So which are the two equations then? Two equations are y equal to minus hx plus root h square minus ab into x rather, or we can take that x common, upon b, and second y equal to minus hx minus root h square minus ab into x upon b. Okay. Now these equations do not contain a constant term. So we can say that these equations, yes, they do represent lines through origin provided. Observe the expression root h square minus ab. So the condition is h square minus ab should be greater than or equal to 0. I hope this is clear to you. Now we discuss nature of the lines. The separate equations of the lines represented by ax square plus twice hxy plus by square equal to 0 are what? We have just obtained this. Y equal to minus h plus root h square minus ab upon b into x, and second y equal to minus h. It is better if we put this in bracket to avoid confusion. Otherwise you may think that only this term is multiplied by x. No. So second is y equal to minus h minus root h square minus ab upon b into x, provided h square minus ab is greater than or equal to 0. Now the nature of the lines clearly depends on the value of h square minus ab. We know that it is discriminant. Now there are three cases. See, we have done this in the topic quadratic equation. There are three cases. the lines will be real if and only if the lines will be real if and only if h square minus ab is greater than or equal to 0. The lines will be real and distinct. See, lines will be real and distinct when h square minus ab is greater than 0. Lines will be real and coincident if h square minus ab equal to 0. Because in that case, what will be the first line? If this part is 0, first line will be y equal to minus hx upon b. What will be the second line? Same, y equal to minus hx upon b. That is why I'm saying that lines are real and coincident, one and the same, if h square minus ab is nothing but 0. And the last case, lines will be imaginary. That is, lines will not exist when h square minus ab is less than 0. So if this is so, then the equation does not represent pair of lines. Okay. Now we are going to discuss sum and product of slopes of the lines represented by ax square plus twice hxy plus by square equal to 0. See, I have mentioned slopes of the two lines. They are m1 equal to minus h plus root h square minus ab upon b, and what is m2? Minus h minus root h square minus ab upon b. If I add these two, I will not show you all the steps, but you know how to add two fractions. So you will notice that m1 plus m2. Can you do this orally? If you cannot, then after the lecture, see how addition can be done. What is sum of the slopes m1 plus m2? It is nothing but minus twice h upon b. If you take the product m1 m2, can you tell me what will be the product? The product is going to be a upon b. You can verify this. See, first plus second into first minus second is square of the first, that is h square. From this is to be deducted. So h square minus h square plus ab. So ab upon b into b square. ab upon b square is a upon b. So the two separate equations are complicated. Slopes are complicated. But you will notice that sum of the slopes is just minus 2h upon b, and product of slopes is a upon b. See, this is the beauty of the equation. Ax square plus twice hxy plus by square equal to 0. Listen to me carefully. If we are given the joint equation, we cannot obtain individual slopes by observation, but we can directly find product of slopes and sum of the slopes. Why? Because if equation is given, coefficient of x square is a. What is b? Coefficient of y square. What is 2h? Coefficient of xy. As simple as that, right? As in case of quadratic equation. If quadratic equation is given, we may not be able to write two separate roots of the equation, but sum of the roots is what? Minus b upon a. Product of roots, c upon a, can be written by observation. Is that clear? So I repeat the statement. If ax square plus twice hxy plus by square equal to 0 represents pair of lines through origin, then sum of the slopes of two lines is m1 plus m2 equal to minus 2h upon b, and product of slopes m1 m2 is nothing but a upon b. Now we will use simple method to obtain this. See, we have considered ax square plus twice hxy plus by square equal to 0. Now divide throughout by y square. If you divide by y square, you get what? Or instead of y square, we will divide by x square. See, I will tell the logic. line through origin is what? Y equal to mx. I hope you agree with this. If a line passes through origin, its equation is of which type? Y equal to mx. So from this, what is y upon x? Y upon x is m. So to get y upon x, what I will divide is, I will divide throughout by x square, not by y square, by x square. Tell me what we get. A plus twice h y upon x plus b y square upon x square, which is y upon x bracket square equal to 0. Is this clear? See, I have begun with this equation. After this, I'm saying divide throughout by x square. So a plus 2h xy upon x square is y upon x. Y square upon x square is y upon x square. Right? Now y is mx because line passes through origin. So I can replace y upon x by m to get which equation? A plus twice hm because y upon x is to be replaced by m plus b m square equal to 0. This is a quadratic equation in m. Bm square plus 2hm plus a equal to 0. Now the roots m1, m2, the roots m1, m2 of this quadratic equation are the slopes of two lines given by this equation. Now can you tell me what is m1 plus m2? Now you should know theory of quadratics. m1 plus m2, yes, you guessed it right. Negative coefficient of m upon coefficient of m square. We obtained the same 2 minutes back. What is m1, m2? Product. It is constant term upon coefficient of m square. Yes. Now first method requires, say, we have to obtain rather two separate equations and then get the slopes, add them, take the product. But this is simple method. Now you will ask me in exam which method is to be used. Obviously first method, because you are supposed to prove that that equation represents pair of lines. Okay. Actually there is one more method. I'll tell you that method also. Suppose m1, m2 are the roots of the quadratic equation in m, where m is the slope. So I can say that m is m1, okay, and m is m2 because m1, m2 are the roots, means values of m. So can I say m minus m1 equal to 0 and m minus m2 equal to 0? Yes, I can. Combine, find joint equation. M minus m1 into m minus m2 equal to 0. Now if you open all the brackets, you get m square minus m1 plus m2 into m plus m1 m2 equal to 0. I hope you are getting this. Now we have said that what is m1 plus m2? m1 plus m2 is nothing but minus 2h upon b. Minus 2h upon b. And what is m1, m2? A upon b. Now, if you rearrange the terms, you get bm square plus twice hm plus a equal to 0. Now, this equation, remember, this equation is called auxiliary equation. I will write that. This equation is called as an auxiliary equation. And the roots of auxiliary equation are the slopes of the two lines given by joint equation. I hope you will be able to write auxiliary equation just by observation. See, I will explain that. What is the original equation? Ax square plus twice hxy plus by square equal to 0. You may say we will divide by x square and so on. Yes, that is correct. But by observation, you should be able to obtain auxiliary equation from this. Working rule is simple. Replace y square by m square. So bm square. Replace xy by m. Okay. And just consider coefficient of x square. See, instead of by square, it is bm square. Instead of twice hxy, it is twice hm. And instead of ax square, it is just a. Of course, you should know the logic also. that if you divide by x square, then you have to replace y by x by m. Why? Because we are discussing line through origin. Its equation is y equal to mx. So y upon x equal to m. Now exercise 4.1, first question. Find the combined equation of following pair of lines. First one, 2x plus y equal to 0. So I will say lines are 2x plus y equal to 0, and which is the other line, 3x minus y equal to 0. Okay. Therefore, combined, that is joint equation is joint equation is 2x plus y into 3x minus y equal to 0. That's it. That's it means, of course, you have to open the bracket. So that gives me what? 6x square minus 2xy plus 3xy minus y square equal to 0. That is 6x square minus xy minus y square equal to 0. This will be asked for 2 marks. But you have to remember, if the given equations are 2x equal to minus y and 3x equal to y, you cannot obtain joint equation directly. Both equations should be written with RHS equal to 0. Then and then only you can combine them. Okay, so this is the first part. Now tell me about second. Actually, it is minus 2xy plus 3xy. So it is 6x square, not minus xy, but plus xy minus y square equal to 0. Second, what are the separate equations? They are x plus 2y minus 1 equal to 0 and x minus 3y plus 2 equal to 0. So this is the joint equation. Now you have to write these steps. Final answer should be x square minus xy minus 6y square plus x plus 7y minus 2 equal to 0. Third part, passing through 2, 3 and parallel to the coordinate axis. Okay, write down. Lines parallel to coordinate axis, write down. Lines parallel to the coordinate axis are x equal to a and y equal to b. Lines parallel to the coordinate axis are x equal to a, small a, and y equal to b. As these pass through 2, 3, as these pass through 2, 3, the point 2, 3. 2 equal to a, 3 equal to b. Therefore, lines are x equal to 2, y equal to 3. Because we have obtained values of a and b, x equal to 2, y equal to 3. That is what? I hope you will not say, so the joint equation is xy equal to 6. That is absurd. We have to rearrange the terms. So x minus 2 equal to 0, y minus 3 equal to 0. Therefore, joint equation is x minus 2 into y minus 3 equal to 0. Now open the bracket and tell me what is the answer. That is xy minus 3x minus 2y plus 6 equal to 0. Right now. Before we start solving fourth one, right in the top margin, slope of line ax plus by plus c equal to 0. Slope of line ax plus by plus c equal to 0 is minus a upon b. Minus a upon b. Okay. Now, the fourth sum is passing through 2, 3 and perpendicular to the lines 3x plus 2y minus 1 equal to 0 and x minus 3y plus 2 equal to 0. See, in CET, we can write directly, but in board exam, we have to write the solution in detail. So write down slope of the line, write down slope of the line 3x plus 2y minus 1 equal to 0. 3x plus 2y minus 1 equal to 0 is minus 3 by 2. And that of x minus 3y plus 2 equal to 0 and that of x minus 3y plus 2 equal to 0 is minus 1 upon minus 3 equal to 1 by 3 equal to 1 by 3. Therefore, slopes of required lines perpendicular to them will be, see on the screen, will be, now product of slopes of two perpendicular lines is minus 1. So their negative reciprocals will be what? See, I have written it on slate. Will be minus 1 upon minus 3 by 2 and minus 1 upon 1 by 3. That is 2 by 3 and minus 3. Okay. Now what is given? Lines pass through which point? 2, 3. So write their individual equations and then join them. Their equations are y minus 3 equal to 2 upon 3 x minus 2 and y minus 3 equal to minus 3 into x minus 2. So separate equations are what? 2x minus 3y plus 5 equal to 0, 3x plus y minus 9 equal to 0. You have to be careful. Joint equation is, do not write in this fashion. You have to show that step, opening the brackets and so on. So what is the final answer? 6x square minus 7xy minus 3y square minus 3x plus 32y minus 45 equal to 0. Complete the solution. Fifth part is for homework, but I will just give you the hint. In fact, hint is also not required. They say one is parallel to and other is perpendicular to. But at least I will give the answer. See, slopes of the required lines will be what? Slope of the given line, first given line is minus 1 by 3. Slope of the first required line will be the same because parallel lines have the same slope. Slope of the given second line is 2 by 3. Now required second line is perpendicular to it. So it is minus 1 upon 2 by 3. That is minus 3 by 2. So the slopes of the two lines will be what? Required lines. I mean minus 1 by 3 minus 3 by 2. Now both lines pass through minus 1, 2. Obtain separate equations. This is the answer for joint equation. So that's it for today.